Let's solve the following linear inequality. What we'll have to do here, first we'll have to find out critical points in order to solve this particular inequality. To do that, all we have to do is you take the numerator, which is x minus 3, and equate it to 0. And we also take the denominator and equate it to 0. That's going to give us two values of x. One is going to be x equals to 3 and the other one is going to be x equals to 5. Now what we'll do, we'll take a number line, a real number line, and on it we're going to consider these 2 points. So 3 is going to come before 5. Now we'll have to consider a few values of x which will be to the left of 3 or less than 3. Some values is going to lie between 3 and 5 and values of x which is going to be greater than 5. So let's consider a value of x which is less than 3. So for instance, let's say if we consider x to be equals to 2, once we take this value, we'll check what is the nature of x minus 2 over x minus 5. This is the only nature of it that we are going to check. So let's substitute this value. So this is x minus 3. So we have 2 minus 3 divided by 2 minus 5. So 2 minus 3 is negative 1 divided by 2 minus 5, which is negative 3. So the negative and negative goes away. So we are left with 1 over 3, and this is a positive value. So this is not the only value of x that you can use. You can use any other values of x, which it has to be less than 3, and you will see that you are always going to get a positive value. So we're going to note down here that this is a positive region. So that means for any values of x less than 3, we are going to get a positive value for x minus 3 divided by x minus 4. Next, we're going to take a value between 3 and 5. So let's say if we take the value x equals to 4, and we are going to use this value and substitute into x minus 3 divided by x minus 5. So we have 4 minus 3 divided by 4 minus 5. 4 minus 3 is positive 1 and 4 minus 5 is negative 1. So that means we are getting a negative value. This tells us that any value that we pick up between 3 and 5, it is always going to be negative. So it's not necessarily that you can pick up x equals to 4. You can pick up, let's say, 3.1 or 4.99. You can check out that it's always going to be negative for values between 3 and 5. We're not going to consider 3 and 5. These are critical points. We are only going to take values which is either less than the critical point or greater than the critical point. And finally, if we take value greater than 5, so let's say x equals to, we'll take a higher value. Let's say x equals to 10. Then in that case, we have 10 minus 3 divided by 10 minus 5. So that will be 7 over 5, which is going to be a positive number. So that means for values of x greater than 5, we are going to get positive values. Right? So this is how values of x are going to behave along the number line. Now coming to our inequality. So here we are given, we have x minus 3 divided by x minus 5, and the value of this rational fraction is greater than 0. That means it has to be positive. So if we look at the number line, so we will say that for values lying between negative infinity to 3, and for values lying between 5 to infinity, we have positive because it's greater than 0. That's the only interval that we're interested in. We're not interested between 3 and 5 because here it's negative, and our inequality is saying that x minus 3 over x minus 5 is positive. That is greater than 0. Now, negative infinity is not bounded, so that's why we're using an open interval. What about 3? So we are not going to consider this particular critical point 3. Anyways, it's greater than 0, so that has to be we have to use an open interval here. Similarly, for 5, this is going to be an open interval, and infinity is always unbounded, so that's an open interval. And we have to use the symbol union, which means that all the values between negative infinity to 3, including all the values between 5 to infinity. So this is the solution set to our given linear inequality.